We are going to start today with our lab experiment 5, which is about series connected resistances. Now, here is our template for this activity, and our objective for the activity is to verify the principles na governing series connected resistances. So we identified last time that there are three, no? There are three equations that describes these principles. So that's what we will be checking using our FET simulator today. No? Now, so as a way of preparing your video presentation, this is your guide again, where you will have a diagram to place, procedure to write, and here's your data. No? So your data, you will be constructing a series circuit with only two resistances. No? So after constructing these two resistances, you will determine the total resistance there, no? R sub T, by solving. No? So there's no FET simulator there to record, no? Simply R sub T, but you will be, no, using the formula for series connection. No? Now, for your I sub 1 and I sub 2, no, which are the currents that are flowing in your resistance 1 and 2, are of course, no, measured using the ammeter, no, that is available in our simulator. No? So there are two ammeters for resistance 1 and resistance 2 that are labeled I1 and I2. But there's a third ammeter that we will also attach in our circuit to measure the total current that is flowing in our series circuit. No? Now, likewise, you will be using all the available voltmeters. So there are only two voltmeters in our simulator. So you will need those two voltmeters, and you will just simply transfer the probe to be able to measure also the last value of voltage we call as the total voltage V sub T. No? Now we will be setting up the circuit there, but again, no, the value that we will keep constant here for this activity is the voltage. No? So the voltage of the battery will be kept constant. So your group has to agree, what value of voltage will that be. No? And then the values of our resistances will be increased, no, from trial 1 to 3. So you will have a separate value for resistance 1 and another set of value for resistance 2, but their values has to be increasing, no, from trials 1 to 3. So that's how we set up. And then again, the value of the voltage in the battery must be kept constant, no, from trials 1 to 3. No? Now, so there's no units attached here in our heading, in our table. So maybe, no, you will have to include a unit in each of the values that you will be recording here. No? Okay, now we'll be shifting to our simulator. Now, going into our simulator, so this is now our circuit construction kit, of our FET simulator. So we will be needing two resistances here. So we'll drag, two of these resistances. So they will be connected in series. So we will also need an ammeter to measure it. So we get our ammeter on these boxes on this end. So this is the voltmeter and this is your ammeter. So you'll need another ammeter for your resistance too. So we have now two resistances with ammeters. So we'll be connecting them, so it will be easier for us to measure the currents later on. So in this activity, you'll need only resistances. And the way we change the values of our resistance is by clicking the resistance. And then you'll notice that you can increase the value there, or you can click this button to increase the decimal value of the resistor. But to quickly change the value, then we can probably slide this one. So this one is for the decimal point. Now again, that's how we will be changing the value of the resistance. So for our trials there, we will have an increasing value of resistances from trials 1 to 3. Now next is our battery. So we'll be connecting a battery to our circuit. Now, the value of our battery, you'll have to decide for it. No? So maybe you can click the battery and increase or decrease the voltage depending on what value you're going to decide for your group. No? So maybe now this is your value of voltage. Okay, to increase the decimal number there, then maybe you can click this one. No? Okay, so we have there now voltage rating for our battery. Then we will be connecting a switch. No? So the switch there now allows us to stop or to let the current flow in our circuit. Now another ammeter is needed not to complete our circuit here. No? So this is our third ammeter, and this third ammeter is now our total current. No? So this one will get I sub T, or total current, or this is our ammeter total. No? And all that we need now, since we have the ammeters, then we need the voltmeters. No? Maybe we can position one voltmeter over here, no? And then we'll position another one over here. So the maximum number of voltmeters that are allowed for us to use are only two. No? So we will, since we will be measuring three voltage values, then we will just simply transfer the probe, no, of this voltmeter. No? Now we will be completing our circuit now, and we'll need to add a wire. So to increase or to lengthen the wire, then you just drag it. Huh? You drag one end, and now you'll complete it by closing the last point here. No? So now we are able to complete our circuit. No? So here's our circuit now. And the first value that we'll be determining, no, for our voltage is V1. No? So to determine V sub 1, then we will transfer the probe of our voltmeter. No? So that will give us our V1 now. This will be our V sub 2. Okay. Now, how do we know that the circuit now has these values of voltage? Then we can close by clicking this switch. No, you can click the end, no, this end of the switch, and it will now allow the current to flow. No? So you are going to record, no, the value of your resistance 1. No? So this is the ammeter 1, I1 value. You record it. This is I sub 2, and this is your I sub 3. No? Now this value of the voltage is your V1. No? This will now be your V sub 2. And what about V total? No? So how do we measure the V total? Now, the V total will be measured from this end of the battery, and then the negative side will be placed somewhere here. No? So now this value will give us your V total. No? So you record it, no, for each of the different trial. No? So let's say we will disconnect, no, our circuit, so we can disconnect that one. No? So now basically this is our, no, first. This is our activity for experiment number 5: series connected resistances. No? Okay, at this point now we will try to make mention now our as a continuation, we will go into experiment 6 now, and this is the last one that we will be doing. This is now about parallel connected resistances. No? So we prepared earlier now a figure for series connection in our FET simulator. So we will just try to revise the way it looks. No? Now, the objective of the activity is, again, very similar to experiment 5, but this time, no, what we will verify are the principles that governs the parallel connected resistances. No? So, of course, there are also 3 sets of equations that governs our parallel connected resistances. No? Now, the same simulator are we going to use, no? And we will have, no, this similar table again, but this time the way our R total, no, is to be solved, since R total cannot be taken from the simulator. So once you know the values of R1 and R2, just like our series connection, we will calculate this column. No? And below, no, there is a computation formula that we can use. No? So once we have this recorded, no, R1 and R2, then we will solve for R total. No? Now, I sub 1 will still be the ammeters that we set up in our circuit, including I total, except that this time, no, they are now attached, no, in a different way. No? Now, you'll see the setup, no, when we connect that, no, using our FET simulator. No? Now, again, no, the 2 voltmeters that we simply transfer their terminals, no, are V1, V2, and V sub T. No? So again, please be reminded that you are to record the corresponding unit, or to write also the corresponding unit for each of our values here. Okay, now we will try to transfer to our FET simulator. Again, a reminder, resistances will be increased. You will have an increasing value of resistances, whereas the voltage value of the battery will be kept constant. So your group again now will decide what value is that, or you can carry on the initial value of battery that you use for the previous experiment on series connection. Okay, now let's shift to our simulator. So earlier we have these sets of resistances. So we have two pairs, or a pair of resistance and ammeter. So all that we will do is to disconnect them and to arrange them in such a way that you will now have parallel connection. So again, the previous value that we have there, we will simply align them. So in parallel connection, of course, maybe now we will position it this way. Okay, so we have now two sets of parallel connected resistances now with ammeter. And maybe what we need there is simply a wire at the top to be able to connect our device. Okay, so you have to set the values of your resistances, of course. Let's connect a wire here. So this will be our first connection over here, and then for the next device. Okay, and then we have here a switch, and this is now our total resistance. Now this is for our I1, this is for our I sub 2. But what we have next is our I3. So this is our I sub 3 value, or our I total, I mean. So these are all in ammeters, or in ampere. So because they are ammeter values. Again, if these are R1 and R2, then therefore you have to increase the value here as we move from trial 1 to 3. Trials 1, 2, and 3, you will have an increasing value of resistance here. Now, again, we change the value of the resistance by clicking the resistor and sliding this button. So changing the value of the resistance. So clicking the resistance itself allows you to change its value of resistance. Now, for our first value of voltmeter reading, so V1, we'll connect the voltmeter here. So this will serve as our V sub 1. Next, this will be our V sub 2. So our V sub 2 will be in volts, and V sub 1. Okay, again, how do we gather the data now? We click the switch to close, and we will now have a value for our voltages. So this is our V1 again, this is our V sub 2. And then for our V total, we'll have to transfer the voltmeter over here to be able to get the voltage V sub T. No? So you can now unswitch or open the circuit there or open the switch. No? And therefore now everything now gets back to zero. No? So again, closing it allows you to measure the different ammeter readings and the voltmeter reading. So this is now your V total. By transferring it over here, then that gives you now your V sub 1. No? So we will just keep V sub 2 steady. So we will only bother with V1 and V total, no, in measuring the two voltage readings. No? So that's the basically the activity. No? So hopefully that's clear, and God bless in your activity.